Good morning to students. Today let us study about one more new theorem, that is most important theorem, that is Pythagoras theorem. Student, this is one of the greatest theorem and also very important theorem for in our annual exam. This theorem is most important in your annual exam, that is 5 marks question is the most important theorem, that is Pythagoras theorem. In your question paper, this question is asked, state and prove Pythagoras theorem. Directly question is asked this step only, state and prove Pythagoras theorem, but a statement is not given. First of all, you can write this statement. In your statement of Pythagoras theorem, in your theorem statement, the square of the hypotenuse is equal to the sum of the square of other two sides. Yes or no? In your right angle triangle only. In your statement is in a right angle triangle. In a right angle triangle. Right angle triangle. Square of the hypotenuse. Square of the hypotenuse is equal to which one? Sum of the square of the other two sides. Sum of the squares of the other two sides. This is your theorem statement. Pythagoras theorem statement. In a right angle triangle, square of the hypotenuse is equal to the sum of the square of the other two sides. This is your theorem statement. But in your question paper directly given a state and prove Pythagoras theorem, but not given statement directly. But first of all, you can write the statement. Our statement is in a right angle triangle. One triangle is there. That a triangle is right angle triangle only, not only acute angle and obtuse angle. Only in a right angle triangle, square of the hypotenuse is equal to the sum of the square of other two sides. Our statement is complete. Our statement is for 1 marks question is complete. Next, one more, you can draw the diagram. Our right angle triangle diagram. Next step, diagram, right angle triangle. Consider this is ABCD is the right angle triangle. Consider A, B, C is the right angle triangle. Right angle at B. Right angle at B is the. Next, one more, a small construction is the. Our construction is, you can draw BD. BD perpendicular to AC. BD perpendicular to AC. Your construction is the. Next, students, first one is statement is complete. Next, proof is complete. Next, you can write the given. First of all, given. What is given? Or data. First step is given. Given or data. In your given statement, what is given? In your given statement, what is given? A right angle triangle is given at right angle at B. In a right angle. Right triangle A, B, C, but right angle at which one? B. This is given. In a right angle triangle ABC, right angle at B. This is given. Next, which is construction is the? Our construction is what? Construction. Very good. Construction. What is the construction? Our BD is perpendicular to AC. BD is draw BD. BD is perpendicular to AC. This is complete. Next, once again, to prove is what? What you can take proof. Next step is what? To prove. Our proof is what? To prove. You can show that you are the meaning of a statement? Square of the hypotenuse is equal to the sum of the square of other two sides. Student, in a given triangle ABC, which is hypotenuse side? AC is hypotenuse. Other two sides are AB and BC. You can write your condition is our AC square is equal to AC square means what? Square of the hypotenuse is equal to the sum of the square of other two sides. Other two sides means one is AB. AB square plus once again BC square is there. You can show that this is our theorem. How to prove of this one? Our data is clear. Next construction is clear. Next proof is clear. One more step is what? Proof. Proof of your theorem. How to proof of this theorem? How to proof of their theorem? Student, maybe in your previous class you can study about this figure only. In your figure, some three proofs are complete. For example, directly in your figure, our AB square is equal to AD into AC, that is whole square in your previous class. Again one more, BC square is equal to DC into AC. Again one more condition or criteria, our BD square is equal to AD into DC is clear. But we want our theorem statement AC square is equal to AB square plus BC square. How to prove this one? Very simple is the first of all you can consider in our previous class first two criteria. First you can consider one triangle and whole triangle in a given figure. Our first proof very simple is our first part only in part 1 in a triangle. In a triangle, first one is what? Small triangle ABD triangle. ABD. One more triangle is what? Whole triangle. Triangle ABC. Once again, one question is the student, these two triangles similar or not?
Yes, sir.
These two triangles are similar because by which criteria? A. Write the given things in a given triangle. First angle is what? Our first one angle in ABD. One more triangle ABC. First right angle is that in a ABD triangle, angle ADB is equal to one more angle ABC, because right angles are there. Right angles. Clear? This is clear. One angle is clear. What about one more angle? Angle A is common angle. Yes or no? Angle A is equal to angle A. Yes or no? That is common angle. This region is common angle. Common angle. Clear? Two angles are equal, therefore automatically these two triangles are similar. Triangle ABD similar to triangle ABC by the condition is what? A criterion. Criterion, yes or no? When these two triangles are congruent, similar, you can write the ratio. What is the ratio? Our corresponding sides are there. AB divided by AC is equal to, once again, AD divided by AB. Next, cross product. Our cross product is what? AB into AB. AB square is equal to AD into AC. You can consider this is equation number 1. First equation is clear. Again, next, you can consider one more triangle. First one small triangle and whole triangle. One more triangle. In this one, second form. Our second form in a triangle. In a triangle BDC. One more triangle. Whole triangle ABC. Again, the two triangles are similar or not? First triangle and whole triangle similar. Again, A criteria. Again, A criteria is the, for example, in a given two triangles, in a BDC triangle, one more ABC triangle. Two triangles are similar. First one is the right angle is the angle BDC is equal to one more angle ABC. Why two angles are equal? Right angles. Directly right angles are there. Right angles. First angle is clear. One more angle. In this one, A is equal to A common angle. In this side, angle C is equal to angle C. This is common angle. Common angle. Clear? Again, two triangles are similar or not? Similar directly. A criteria. Therefore, triangle BDC DC similar to triangle ABC because AA criterion. Yes or no? Clear? When these two triangles are similar, automatically our corresponding sides are in the same ratio. Our corresponding sides are in the same ratio. But in first equation, our AB square is clear. In this side, you can take BC square. Right? The ratio means therefore our BC divided by AC is equal to DC divided by BC. Again cross product. Our cross product is what? BC into BC. Therefore BC square is equal to DC into AC is this is equation number 2. Sir, what next? Our next is add equation 1 and 2. Next step is what? Add. Add equation 1 and 2. Our first equation is AB square is equal to AD into AC. Our second equation is BC square is equal to DC into AC. So you can add both. Therefore, AB square plus BC square is equal to AD into AC plus again BC into AC. In left side same as it is, that is right. Therefore, AB square plus BC square is equal to, in a given two steps, which is common is the AC is common, take outside AC into bracket of AD plus DC. Yes or no? Again write therefore AB square is again plus BC square is equal to AC into student. What is the value of AD plus DC means what? AD plus DC. Total is what? Right? AC directly. Therefore, our AB square plus BC square is equal to AC square. Yes or no? Proof of our theorem. Therefore, directly AC square is equal to AB square plus BC square. Hence the proof of theorem. Hence the proof of theorem. Hence the proof of. Hence the proof. Yes or no? Our theorem statement. Square of the hypotenuse is equal to the sum of the square of other two sides. This is only our Pythagoras theorem statement. Very simple is the, in a given triangle only you can consider two pair only. Two pair of triangle. One is small triangle, one big triangle. One first ratio. You can get first equation. Again one more. This small triangle and whole triangle. Two triangles are similar. Again you can get second equation. Last only directly addition of two equations you can get the condition. AC square is equal to AB square plus BC square. Okay? Thank you. Right. Right now.